Chapter 6, Fundamental Valuation Concepts. We will be now getting into details about fundamental aspects. These are nowhere related with the operations of the stock exchange. Fundamental valuation concepts, the basic objective of introducing this particular chapter is to make understand the trading member and the users in that particular trading member group need to have certain basic knowledge about how the fundamental concepts of a particular company affects the valuation on the stock exchange operations with respect to the security valuations. If the particular trading member and their group are aware about the fundamental valuation issues, they will be in a position to properly guide the investor, because the investor looks towards the trading member group to advise them accordingly for the planning of their investments. So to have certain basic idea about the investment and valuation of the companies, these people are necessary to understand the various fundamental concepts. With this objective in view, fundamental valuation concepts gives better insight about the price movements of various securities on the stock exchange. This particular chapter, Fundamental Valuation Concepts, has 6% weightage on the examination of NCFM Capital Market Dealers module. This is a very important aspect to understand the valuation process. Let's try to get into details about fundamental valuation concepts. First, time value of money. Money has time value. A rupee is less valuable in the future than it is today. Time value of money could be studied under the following heads. 1. Future value of a single cash flow, future value of an annuity, present value of a single cash flow. Finally, fourth point, present value of an annuity. We will try to get into these four aspects of arriving at the valuation of money. The future value of a single cash flow. For a given present value of money, the future value of money after a period, let us say T period, T time, for which compounding is done at an interest rate of R, is given by the equation future value is equal to present value into 1 plus R to the power of T. That means if I am making certain investment right now, that becomes the present value. So we are trying to calculate what can be the value of this present amount after a period of T time and at an interest rate of R. This assumes that compounding of this present value amount is done at discrete intervals. However, in case of continuous compounding, the future value is determined using the formula future value is equal to present value into e to the power of RT, where the compounding factor is calculated by taking natural logarithm. The logarithm of base, the value of E is 2.71828. Now, let us take one particular example and try to calculate the future value. Calculate the value 5 years hence of a deposit of 1000 made today if the interest rate considered is 10%. Let us take a discrete compounding methodology. As we have already seen, future value is equal to present value into 1 plus R. whole to the power of t. Here the present value is 1000, the time frame taken is 5 years, and compounding will be done every year, and rate of interest that will be charged is 10%. Then what happens to the future value calculation? Future value is equal to 1000 into 1 plus 0.10, because 10% means 10 by 100 gives 0.1. So R is substituted by 0.1. So 1 plus 0.1 to the power of 5. When we calculate, it gives 1000 into 1.61051. Finally, the amount becomes 1610.51 paisa. That means 1000 rupees which is invested now, after 5 years at an interest rate of 10%, it becomes 1610 rupees 51 paisa. So 1000 rupees becomes 1600 rupees change after 5 years if we work out at an interest rate of 10% per annum. If we are using the same methodology in a continuous compounding pattern, future value is equal to present value into the logarithm of e to the power rt. So future value is equal to 1000 into 2.71828 to the power of r, that is 0.1 into time 5. This works out to 1648 rupees and 72 paisa. So if we are using discrete compounding methodology, 1000 rupees will become 1610 rupees after 5 years at 10% interest rate. If we are following a continuous compounding, that is regular compounding methodology, our formula is slightly different, and this particular 1000 rupees, if we treat it on a continuous compounding basis, will works out to 1648 rupees change after 5 years. So this is how the present value is used for calculating the future value based on discrete compounding and based on continuous compounding. So these are the two different formulas for purpose of calculating the future value. Now let's try to see one more example. Find the value of 50,000 deposited for a period of 3 years at the end of a period when the interest rate is 10% and continuous compounding is done. So future value is equal to 50,000 into e to the power of rt. So this works out to 67,493 rupees. So 50,000 invested today, after 3 years at a 10% interest rate using continuous compounding method will change into 67,493 rupees. That is increment of 17,493 rupees for an investment of 50,000. Now the future value of the present sum, that is the present value, after a period of time t for which compounding is done m times in a year at an interest rate of r, is given as per the equation. The future value is equal to present value into 1 plus r by m to the power of mt, because we are compounding at an interval of m times in a year. Let's try to see one example to understand this particular future value calculation. How much does a deposit of 5,000 grow at the end of 3 years if nominal rate of interest is 10% and compounding is done quarterly, that is every 3 months. Future value is equal to 5,000 into 1 plus interest rate of 0.1 divided by 4, because in a year there are 4 quarters and every quarter we want to use it for compounding purpose. So it becomes 0.1 divided by 4 to the power of 4 into 3. So 4 quarters in a year into 3 years. So it becomes 12. this value works out to 6,724 rupees. So this is how future value is calculated with compounding of every quarter. Now, future value of an annuity. Annuity means every year we are investing. In the previous case, we have put the present value amount in one go at the beginning of the period and waited till the end of the period of, let's say, 3 years or 5 years. Here what are we doing is, we are investing a certain amount, selected certain specified amount at the end of every year till the completion of the period or the term. That means every year, every annual, we are investing certain fixed amount. So how do we calculate the future value in such case? Future value of an annuity, future value of a uniform cash flow made at the end of each period till the time of maturity T, for which compounding is done at the rate R, is given as future value is equal to cash flow, that is the uniform cash flow, into 1 plus R to the power of T minus 1 plus cash flow into 1 plus R to the power of T minus 2 plus up to plus cash flow into 1 plus R to the power of 1 plus finally cash flow. That means today if I am investing certain amount, 1000 rupees for 5 years, the interest should be calculated for 5 years for the amount I have invested now at the beginning, that is at the point 0. After 1 year, again when I invest another 1000 rupees, then I have to calculate interest for only 4 years, because it is a term of 5 years. So in the beginning if I invest, I have to charge interest for 5 years, and if I am investing after 1 year, only for 4 years interest has to be calculated, and after 2 years if I invest once again 1000 rupees, only for 3 years the interest has to be calculated. That is how T minus 1, T minus 2, T minus 3, T will come into the picture. This is how the calculation is calculated in this particular methodology. Suppose we deposit 1000 annually in a bank for 5 years, and your deposits earn a compound interest rate of 10%. What will be the value of this series of deposits and annuity at the end of 5 years? Assume that each deposit occurs at the end of the year. Future value of this annuity is, first 1000 into 1.10 to the power of 4 plus, again when we are investing after 1 year another 1000 rupees, 1000 into 1.1 to the power of 3 plus 1000 into 1.1 to the power of 2 plus 1000 into 1.1 plus 1000. This is how for 5 years investment the interest rate is calculated accordingly depending on the period left for calculating the interest. This amounts to 6,105 rupees. In case of continuous compounding, the future value of annuity is determined using the formula future value is equal to cash flow into e to the power of RT minus 1 whole divided by R. This is a formula used for such a case. Now, present value of a single cash flow. We have seen future value of a single cash flow. We have seen future value of a annuity. Now we are seeing present value of single cash flow, present value of the future sum to be received after a period T, for which discounting is done at an interest rate of R, is given by the equation in case of discrete discounting as follows. Present value is equal to future value divided by 1 plus r to the power of t. It is just a change of the main formula. Future value is equal to present value into the 1 plus r to the power of t. Now if I want to know the present value, I have to divide future value divide by 1 plus r to the power of t. That means if I want certain amount after 5 years, then how much should I invest right now? The rate of interest expected is r. This is what we are trying to find out. What is the present value of 1000 payable 3 years hence if the interest rate is 12% per annum? Present value is equal to 1000 divided by 1.12 to the power of 3. That becomes 711 rupees 78 paisa. That means if I want 1000 rupees after 3 years, I need to invest 711 rupees 78 paisa today, expecting an interest of 12% for next 3 years. In case of continuous discounting, what is the formula? Present value is equal to future value into e to the power of minus rt. What is the present value of 50,000 receivable after 3 years at a discount rate of 10% under continuous discounting? If we are calculating future value, we do continuous compounding. If we are doing present value, we do continuous discounting. Present value is calculated as follows: 50,000 divided by e to the power of 0.01 into 10 into 3. This works out to 37,041 rupees. That means if I want 50,000 rupees after 3 years with respect to continuous discounting process of 10% per annum, I need to invest today 37,041 rupees. If I invest 37,041 rupees today with the expectation of 10% per annum for 3 years on a continuous discounting basis, I will be expected to receive 50,000 rupees at the end of the term of 3 years. This is how we calculate the present value. Present value of an annuity. This means how much amount I need to invest every year so that I receive certain expected amount after certain period. The present value of annuity is the sum of the present values of all the cash flows or outflows, inflows. Present value of an annuity in case of discrete discounting is calculated as follows: present value is equal to future value into 1 plus r to the power of t minus 1 divided by r to the power of 1 plus r to the power of t. Present value of an annuity in case of continuous discounting. Present value of annuity is equal to future value of annuity into 1 minus e to the power of minus rt divided by r. This is the formula used for continuous discounting on an annuity basis. So if I calculate this on annuity basis, what is the amount I have to deposit at the end of every year starting from 0 period? This is how it is calculated. If I am expecting certain amount, what should be the present amount I should invest every year? This formula helps me to arrive at that particular value.